Okay, as promised, we're going to do a couple more examples of how to graph these by hand in case you don't have a graphing calculator handy. Okay, so we're going to start with the axis of symmetry. So we're going to use that formula, x equals negative b over 2a. So in this, we have negative 2, 4, and 1. So a is negative 2, b is 4, and c is 1. I automatically know that this is going to be opening down. Okay, opens down because a is a negative value. Okay, so let's go ahead and plug this in. We have a negative, and then we plug in b is 4, and then we have 2 times a, which is negative 2, so we end up with negative 4 divided by 2 times negative 2, which is negative 4, so x is 1. So our axis of symmetry is going to be at 1. So this is where our axis of symmetry is going to lie. Okay, now we need to find our vertex. So our vertex, we know that x is 1. Okay, so in order to find y, we plug it in. So y is equal to negative 2 times x, which is 1 squared, plus 4 times 1 plus 1. Plug all of that in. We have 1 times 1, which is 1, times negative 2, which is negative 2. 4 times 1 is 4. And then we simplify. Negative 2 plus 4 is 2, plus 1 is 3. So our y value is going to be 3. So when x is 1, y is 3. Okay, then we're going to plug that in to our table. Okay, and then we're going to go 2 places to the left, so 0 and negative 1 seems like a good place to go, and 2 to the right, 2 and 3 seem like a good place to go. All right, so to find those values, remember, I do not have to use my calculator. I can plug in any of these x values into the equation to find out what the y value is that corresponds with it. But I can also use my calculator, which is a little bit easier, a little bit faster. So I'm going to do y equals. I'm going to type in negative 2x squared plus 4x plus 1. And I'm going to do the second graph function, which will give me the table. And then this is my table. Okay, so I am looking for the y value that corresponds with 0, which is 1. The y value that corresponds with negative 1, which is negative 5. The y value that corresponds with 2 is 1, and the y value that corresponds with 3 is negative 5. So now we're going to plot those points, okay? So since it opens down, our vertex is going to be a maximum, all right, at 1, 3, meaning no other points above that. It's going to be below that. Then we have 0, 1, and negative 1, negative 5. And then we have 2, 1, and 3, negative 5. Okay? And again, when we graph this, it's going to be a nice smooth curve, no point to it. And those lines are going to extend forever down and out. So in this case, again, domain, we have x values that keep going forever to the left and the right, okay? So they're going to keep going all this way, all this way. So our domain is going to be all real numbers. And if you remember, that is one of the traits that we talked about of a quadratic. Domain is usually going to be all real numbers, okay? The range here is everything that is below this vertex. So the vertex here is at x equals, let's see, 1, y equals 3. So it's going to be everything below 3, okay? So y is going to be less than or equal to the value of 3, all right? So that's how we solve that problem. Now, we have one more example I'm going to do. I'm going to drop down and do this number 7 with you, okay? So if you look at it, we have a is equal to 2, b is equal to 8, and then remember out here there is no c value, so c is equal to 0. So if I plug this in to find my axis of symmetry, first off, let's remember this is a positive a, so it's going to open up. X is equal to negative b divided by 2a. That's our axis of symmetry formula. So negative b value is 8. A value is 2, so negative 8 divided by 2 times 2 is 4. Simplify that to give us negative 2. So our axis of symmetry is negative 2. And then we plug in that value to find out what y is going to be. So y is equal to 2 times negative 2 squared plus 8 times negative 2. So negative 2 times negative 2 is 4. 4 times 2 is 8. 8 times negative 2 is negative 16. So y is going to be negative 8 in this case. Okay, so x is negative 2, y is negative 8. So I'm going to go ahead and plot that point. 1, 2, 1, 2, 3, 4, 5, 6, 7, 8. And it is going to be opening up, so this is going to be our lowest point. It's going to be our minimum. Okay, so I'm going to plug that into my table. And then with my calculator, I'm going to plug in this information. Okay, so here's my calculator. I'm going to go to y equals, clear out what I already had there, and I'm going to plug in 2x squared plus 8x. And instead of hitting graph, remember I'm going to hit table. And I'm going to look at these values. So I'm going to go, I have negative 2 as my vertex. I'm going to go 2 places up. So I'm going to go to negative 4 and plug in 0. And negative 3 and plug in negative 6. And then I'm going to go below that. So negative 1 is negative 6 and 0, 0. All right, so those are all the points that I wanted to fill in. Now I'm going to graph those points. So I start with negative 4, 0, 1, 2, 3, 4, 0. Negative 3, negative 6, 1, 2, 3, 4, 5, 6. Negative 2, negative 8 I've already got. Negative 1, negative 6. And 0, 0, the origin. Okay. And now that I have the points, I can go ahead and graph this as a smooth curve, not a point, okay? And I can look at our domain and range. So again, domain, our values extend left and right forever, so it's going to be all real numbers. But our y value starts here at negative 8 and continues up forever. So y is going to be greater than or equal to negative 8.